Good afternoon to all.
Good afternoon, sir.
Visibility of the screen,
Yes, sir.
is it okay?
Yes, sir. Okay, sir.
Yes, sir. Okay, sir.
So, in the previous session, some of the fundamentals we have discussed. So, abbreviations are related to abbreviation, software's definitions. So, CATIA we are exclusively using for this particular surface modeling, and this is developed by Dassault Systems, all these things. And ProE, it is developed by, what is the company? ProE is developed by PTC company. So it is used for large assembly sections exclusively, ProE or Creo, whatever may be. Okay, we call it Creo. So unique graphics. So it is in the past, it was it was called PLM software. Product lifecycle management. This particular product lifecycle management. It was originally developed by UGS Corporation. Now it is on Siemens NX. So that have been completed. Generative design. So sometimes we may have the topic related to this generative design. See the definition of this particular concept. So it is a iterative design process. It involves a program generate number of outputs to meet certain constraints. That means, so here the designer who is going to be develop a product, he is going to select from the feasibility. He is going to check the feasibility by changing minimal and maximum values of interval. Variable of program meets set of constraints. So definitely he should meet his output. Whatever may be the product developed by him, it should meet some constraints. So strength it may have the constraints, and sometimes material constraints, sometimes movement constraints, everything. It should meet the constraints of the outputs. So certain number of outputs will be revealed. So from that, after he has to check the to meet the constraints. Then he has to choose final model. So similarly, topology optimization also. So in the last session, we just orally I have discussed. So now you can view the topology optimization. So it is also one of the important topic in the design or product development regarding product development. So topology optimization is a mathematical method. It's a mathematical method that optimization material layout within the design space. It's, here we are going to consider here also of loads. What kind of loads? It may be a concentrated load, it may be uniformly distributed load, or it may be a triangular load. Whatever may be the load acting on a particular component. So theoretically, we are going to assume all these loading conditions, as you know about this completed in your strength of material subject itself, and there will be boundary conditions related to degrees of freedom. So there will be some boundary conditions and constraints also. So we need topology optimization is definitely we are aiming to maximize. Here our aim is to maximize the performance of the system. Definitely we have to go through all these things, that is shape optimization. So that shape should be optimized. That means if you optimize the shape, definitely the material will be optimized. The output or from this particular optimization, we are going to get material will be optimized by optimizing the shape. I mean unnecessary materials will be removed, and size optimization. Here also, so if you are, if your loads are small, or if you are applying low amount of loads, then the size of the component will be reduced according to the loading conditions, and the direction of the load is also important. So in which direction the load is going to apply, that is also taken into the consideration when 3D component is designed or modeled. So here within the design space, instead of dealing with predefined configurations, this is things. And also step file and IGES files. Step file, so it is also used by different, it's a CAD file format usually used to share 3D models between user and the CAD systems. So from the definition itself, so it is, they have given the abbreviations standard for the exchange of product model data. So it is a interface between the user and the CAD systems. And we are having IGES files. IGES files a transfer of geometry data and CAD models. It is used to represent both the boundary representation. We call it in short form. It is BREP, boundary representation, and construct solid geometry, CSG geometries, as well as two-dimensional CAD diagrams. So all these things are related to product development before product manufacturing. In the software itself, we need to the supporting formats. These are the IGES format. The the manufacturing system. For analysis, we have to complete both modeling and analysis in the system itself, in the PC itself. Then we call it as complete 3D object. Once we complete modeling, that will not be a product unless we complete the analysis part. Analysis part also plays major key role in the product development. So between modeling and analysis, we need to import the file in this format. That is initial graphics exchange specification. The short form is IGES files. So the basic difference. So here IGES and step files are widely neutral CAD formats acceptable in all softwares. So in IGES output is in surface, while step files keeps the SC hierarchy. So if you this particular IGES files, differentiation, they are going to differentiate these particular formats. So in IGES, the output both volumes, solids, definitely solid is concerned, it must have some volumes. It is having some volume and our surfaces also. So step files is more supporting, it is more supported, mostly supported by all CAD softwares. See next. So this is one of our fifth chapter in our course, Stl File. Just I will brief this, and we will go in detail in the classes. Stl File, that is standard tessellation language. The full form of this Stl file is standard STL. So this is basically, this particular format is used in the 3D printing machines, whereas IGES files or step files, those files are in the for the CNC machines also. Those particular formats are supported by CNC machines. Here STL file, it is developed by stereolithography in 80s by so CAD data for the 3D printers. So this way it was developed for the reason of it is a CAD data required for 3D printers to print the product. So in order to understand the file better, we are having 5 vital things to need to understand about Stl file format. So I think you have understood the statement. So 5 things to be remember when you are going to read about or discuss about the Stl file format. So see, other 3D printing formats along with this Stl file format, we are having other formats also. Those are OBJ, VRML, Ply, etc. We may or may not aware of all these formats, but in our syllabus we are limited to Stl file. That is, the saving format is .stl. The saving format of Stl file is .stl, like our Word document .doc, .xls for a Excel sheet. Likewise, see what is the Stl file from the definition: standard tessellation language or stereolithography. In other words, stereolithography, the ST for stereo and L for lithography. So here, series of linked triangles. Screen is visible. Is screen is visible? Hello. Hello.
Sir, visible, sir.
Okay. Here, a series of linked triangles. So the entire component.
Sir, a PDF open అవ్వలేదు sir.
Now,
No sir, open అవ్వలేదు. అయింది sir. Yes sir, అయింది.
see what is STL file definition? Standard tessellation language. So I have given these details, and it is having this format having the series of linked triangles. See in the from the first slide. So here a component. It is a component which is divided into number of triangles. So this is, I mean, first CAD model we may have different shapes. STL file in the form of series of triangles. Okay. The more triangles used, the higher resolution of 3D model we have. So the triangles, how many triangles we need to do? I mean, if you give, if you are having flexible to make more triangles, then we are the resolution will be depends upon the number of triangles. It's STL file widely used because it is simple. That is a basic thing. And other limitation of STL file. See, all these things are, so there will be some limitations for STL file, and we are having, I mean, problems. STL file only understand external surface and shape of the 3D model. So it may, I mean, it won't go into internal details. That is one of the limitation for the STL file. The second biggest problem, the file is the, I mean, STL files is the gaps and overlaps of joining surfaces. When you are going to join these particular surfaces, we may have some overlaps and gaps between the surfaces. That will be one of the limitations. And other things, furthermore, information such as color, internal structure or texture or attributes that a CAD file holds may not be included in STL file. STL file only related to external surface and shape. They won't include internal structure details. Texture means that is surface. We are having in the, if you are going to design any product, you are having the textures and attributes and details, data about that particular component, and may not be hold included in this. I mean, it will not be included. See, third step. What is the first step? What is the Stl file? Limitations of Stl file. And third one is exporting Stl files using different CAD softwares. So there will be a procedure for every modeling software. So so exporting an Stl file, one of the steps in creating 3D printed models. So here different softwares have different steps to export these files. So Tinkercad. This is one of the modeling software. I'd say here design download for 3D printing .stl. It is very simple. The procedure is very simple. When coming to the Autodesk Inventor, we are having few steps. That is select iPro print 3D print preview. So select options for. So if I say now, you may not understand. If you are once go through the 3D printing system, I mean 3D printing in practice, you may understand this particular procedure. But we need to remember these steps for your examination sake. We need to remember step by step what we have to. So in the preview window, select save copy as and send to 3D printing device. So 3D print service. These are the different steps followed by Autodesk. AutoCAD is developed by company Autodesk. I think most of you are known. So SketchUp is the another software. So it is having own procedure. Likewise, SolidWorks. Likewise, Fusion 360. So these are all softwares, CAD softwares. So sometimes plugins is to be downloaded and installed. In SketchUp, for SketchUp, we are going to download STL plugins also. So we need to follow this procedure, unless we can't export these files for 3D printing. So CATIA, UGS NX. So we are having different procedure. So I will forward this PPT to you. Just go through it and try to remember this procedure. Important settings when exporting STL files. Say angle control, chordal deviation. So chordal deviation means, so chord, what is a chord from basics? Any one of you? Chord. Chord for basic definition. It is the interior of, I mean length which is internal the circle. So when it meets the center of the circle, it becomes the diameter. I think from the lower classes we are going to study. So that deviations and angle controls. So everything, this particular settings when exporting STL files. So let us see what angle control. In the angle control, what we have to perform to improve the print resolution. It is recommended to have gaps between triangles and change its angle deviation between adjacent triangles. So for improving resolution, always if the resolution is good, definitely our printing output component the shape will be good. So gaps between triangles and change its angle deviation. So in this way, easier to adjust and close objects are layered and tiled together. So in all rapid prototyping technique, we are aim to deposit the materials layer by layer. So for depositing the material layer by layer and for getting perfect product output, so our angle control to be adjusted or set. So it is presetted. So likewise, chordal deviation. So maximum distance between the surface of the original design and STL mesh. So meshing So we are having some meshing tools also in in CAD softwares. We are having some meshing tools also. In meshing tools, we call it as if you take hypermesh is the one of the software. So in the modeling, I mean, after the modeling, before the analysis, we are going to have meshing tools also for the finest parts. For getting finest output, we have to go for the meshing tools also. But in ANSYS, we are having some extent we are going to mesh in ANSYS itself. But for high resolutions or high performance, we have to go for the some specific meshing tools. That is some meshing tools that likewise hypermesh is the one of the meshing tool software. So in ANSYS we are having hexamesh, tetramesh likewise. So most of the times we will go for the tetramesh. I mean, depends upon this particular roughness of the component. So if you want a more fine component, more finest component, we have to go for more triangles meshing. So once let me show. So this is meshing. What is this component? Hello, the component. Components. Hello.
Sir,
Component చూసారు కదా
exhaust
నేమ్
fan,
ఇక్కడే
sir.
ఉంది కదా
Exhaust fan.
I mean cooling fan. Okay, and that
Sir,
whatever may be the heat deposited in the CPU or heat dissipated from the CPU, it going to remove the heated air, I mean hot air. So like just for your idea, this is called meshing. So tetra mesh, hexa mesh, we are so the shape, the shapes. If you observe this, the shape is in triangular form. The shapes are in triangular form, and even small geometries. Every geometry having this meshed portion. This process is known as meshing, converting this component 3D model into number of triangles. Say another binary or ASCII. So encoding. These are the encoding and ASCII encoding. So binary files are smaller and easier to share, while ASCII files are visually easy to read and check. And next, say binary format is recommended to use for 3D printing. So binary codes, the from the primary classes, binary code, what is binary code, zero ones, 1001 or whatever maybe. So in those formats from the lower classes, you may understand that. That is ASCII format is suggested. Those who want to manually inspect Stl file for debugging. So manually inspection process for manual inspection process, we will go for this particular ASCII format. See, there are special rules for STL files. So all these things we will go in detail in 5th chapter, just for the sake of what every time I am saying STL file. So for every rapid prototyping, we need to convert into STL files. So in detail, we are going to discuss in 5th chapter. So let us. So already many of the topics have been covered so far from last 1 month. I mean 1 month, 15 days I think completed. See, here so we are having some advantages of the STL file. So provide simple methods of representing 3D CAD data, 3D, I mean 3-dimensional CAD data, and a de facto standard has been used by the most CAD systems and RP systems. So rapid prototyping and CAD systems. So it can provide small, accurate for data transfer certain shape. So the best advantage of the, I mean, best benefit of this particular STL file is to provide small and accurate files. So some particular formats may have large memory. So at that time, the system won't supports. The system configuration must be high. So that, I mean, for example, ANSYS, if you are going to install an ANSYS software into a system, if you are going to perform analysis part of a particular component, then you need to have at least 4 GB RAM. So why? Because the file formats occupies more space uh, in the system. I mean, to run faster rate, you need to have the high configuration systems. 2 GB it won't support. I mean, 2 GB configured systems will not support a design software. At least 4 GB RAM should be installed in your system, PC, personal computers, or whatever maybe laptops. So graphic card, also inbuilt graphic card. If anyone is interested to buy a system for usage of mechanical design softwares for the designing of a particular component, so just better for the high configuration. I mean, with the graphic card, then your design parts will have high, I mean, faster rate. I mean, the development of component at faster rate. Okay, that's your interest. If anyone is really interested to be a design engineer. So the disadvantage, STL is many times larger than the original CAD data. So CAD data we are having less data. What I'm saying now. So STL file will have larger than CAD data, but when compared to other formats, it may be it provide large and accurate files. Accuracy is also one of the key parameter, and that is the advantage. The geometry flaw exists in STL file. So flaws are defects. Here flaws means defects in the file. So subsequent slicing of large STL files can take many hours. Slicing is the one of the sequence of operations in 3D printing. So slicing of large STL files take many hours. That means time duration. So in last class, we left metal 3D printing.
There's one pretty.
let us say how 3D printed, I mean metal for metal parts. Are you able to see screen, video screen? Hello? Hello?
Yes, sir.
Video sound?
Printing technology
Hello?
that's used in full
Sound of video which I am playing. Hello?
సార్ ఒకసారి అడగండి సార్ అందరినీ నా దాంట్లో వీడియో ప్లే అవ్వట్లేదు సార్ మరి
Video
Sound
play out, sir.
Video playout.
I have kept in resume. Just say
Formula One cars, Boeing Skyliners, and even people walking around
Yeah.
today.
Sir.
This technology is known as the holy grail of the 3D printing
Outstanding.
industry.
రావట్లేదు
oh,
సార్
okay.
It can produce strong, functional parts from exotic materials like titanium or stainless steel. And hundreds of millions of dollars of investment are pouring into this industry to make the technology more accessible and more cost effective. Hello, people of the internet. My name's Ben Redwood, and welcome to this episode of What is 3D
సార్
Video
వీడియో రావట్లేదు సార్
printing.
Video?
And of course, today we're talking
రావట్లేదు సార్ ఒక వస్తుంది
స్క్రీన్ అలాగే ఉండిపోయింది సార్ ఇందాకటి వీడియోస్ లిస్ట్ అలాగే ఉంది సార్ వీడియో ఓపెన్ అవ్వలేదు
there's one
Now are you
3D printing
audible?
technology that's used in
Hello?
నో సార్ నో
Formula One cars.
Okay. Huh? వాయిస్ వస్తుందా వీడియోది
వస్తుంది సార్
వాయిస్
Cut out వస్తుంది, sir.
ఏంటండి
Boeing Skyliners, and even people
Hello.
walking around today.
ప్లీజ్
Of the 3D printing industry. It can produce strong, functional parts from exotic materials like titanium or stainless steel. And hundreds of millions of dollars of investment are pouring into this industry to make the technology more accessible and more cost effective. Hello, people of the internet. My name's Ben Redwood, and welcome to this episode of What is 3D Printing? And of course, today we're talking about metal 3D printing. So let's do it. Metal 3D printers use a laser to scan and selectively fuse or melt metal powder particles, bonding them together and slowly building up a part, one layer at a time. They're most commonly used in industrial applications like high-end, complex engineering products. The two most common methods of metal 3D printing are SLM, selective laser melting, and DMLS, direct laser metal sintering. And both of these technologies belong to the powder bed fusion category, like SLS in one of our previous videos. As SLM and DMLS both produce parts in a similar fashion, and the end parts are comparable To save us both some trouble, I'm just going to refer to everything as metal 3D printing for the rest of this video. There are several other 3D printing technologies that can also produce metal parts. Two that are rapidly rising at the moment are binder jetting and metal FDM printing. Hence why we have our friend the Ultimaker back for this video. We'll talk about these cool new technologies later on, so stay tuned. So what are the key steps that a metal printer follows to produce parts? Firstly, the build chamber is filled up with an inert gas. After this, the build chamber and the powder are preheated to an optimal printing temperature. A thin layer of metal powder is then spread over the build platform, and a high-power laser scans the cross-section of the component, melting or fusing metal particles together and creating the first layer of the 3D printed part. Finally, when this is complete, the build platform moves down one layer height, and the recoating blade spreads a fresh layer of powder over the previously printed layer. This process is repeated time. The printing process for metal 3D printing is very similar to SLS, and like SLS, at the end of printing, the parts are fully encased in powder. But there's one key difference. Metal 3D printing always requires support structures, something SLS doesn't need, and we're going to talk about why later on. Let's discuss why you would choose to use metal 3D printing for your design. One of the biggest strengths of metal 3D printing is design freedom. You can now print parts that were previously impossible to produce using traditional manufacturing techniques. Two particular areas where metal 3D printing is having a large impact on design freedom is part consolidation, taking 100 parts and metal printing them to be just a single piece, and the production of parts with integrated lattice or porous structures, particularly useful in the medical industry or areas where strength to weight ratio is very important. Obviously, one of the big advantages of metal 3D printing is metal. Metal has a number of superior properties when compared to plastics, and another advantage is that metal 3D printing can produce parts out of titanium and other advanced alloys. Okay, we know metal is great, but what are some of the limitations of this technology? Compared to traditional manufacturing technologies like CNC machining, the cost of metal 3D printing is high. On average, a metal printed part around the size of your fist will cost about $1,000 to print and finish, with prices rapidly increasing depending on the geometry. In simple terms, metal 3D printing is really only justified if you're going to see a big improvement in performance. Another limitation of metal 3D printing is the build size. The maximum build size for most metal 3D printers is only 200 millimeters cubed, so you should keep this in mind when you're designing your parts. Metal printed parts are...
Hello. Dear students, please respond.
సార్ వాయిస్ మరి వినిపిస్తలేదు సార్.
I have shared computer sound also. వాయిస్ అసలు రావట్లేదా?
ఫస్ట్ స్టార్టింగ్లో వచ్చింది సార్, తర్వాత బ్రేక్ ఆగిపోయింది.
I'm operating with fiber net internet. Okay. And my voice is clear. I don't know. I have shared share computer sound also. I might not know what might be the reason. But anyway, he is saying that the limitations and advantage. The limitations of metal 3D printing is it is having disadvantage. I mean, cost wise. A limitation is cost wise, very high cost when compared to CNC machines. Metal 3D printing machines very high cost, and this is the major limitation of this particular 3D printers.
Never ready to use straight off the build platform. Every metal 3D printed part requires some form of post-processing, be it powder removal, heat treatment, or post-machining. And all of this adds to the cost and lead time of production. When it comes time to start actually designing your parts, there are a few things you should keep in mind. Metal 3D printing is the most difficult 3D printing technology to design parts for. Just like CNC has undercuts and injection molding has draft angles, there are a set of rules that must be followed to ensure your parts print accurately and successfully. Support structures in metal 3D printing serve three different functions. 1. It offers a platform for new layers of the print to be built upon, similar to FDM and SLA. 2. Because of the temperatures involved, metal 3D printing is particularly prone to distortion and warping. To anchor the parts to the build plate and to help combat warping, we use support structures. And 3. They act as a heat sink, drawing heat away from the part and allowing it to cool more uniformly. Because of the high dependence on support material, part orientation is critical. When designing for metal 3D printing, the main goal should always be to reduce the dependence on support material, as this adds cost and time. As a rule of thumb, any overhanging angles should not surpass 45 degrees. Metal printing allows you as a designer to produce parts that include lattice structures. These structures are fantastic for maximizing the surface area in a heat exchanger or improving the strength to weight ratio of a part. Other new CAD techniques like topology.
What I have discussed in the first few minutes of this session, topology optimization. See, let us hear him from his voice also.
Optimization and generative design are also perfect to utilize with metal 3D printing. One important thing to keep in mind is whether all parts of your design actually need to be metal 3D printed. Often, it's better to choose a traditional manufacturing technology like CNC for some of the more basic sections and then use 3D printing for the complex parts, assembling these all together at the end. This can save a lot on the overall cost of your design.
What he is
For
saying,
specific design rules that you should
machine మీద చేస్తే అదే machining process. Cost, I mean assembling it takes one more cost for the CNC machining. Assembly it's also a cost consumption process. So whereas 3D printing is concerned, so assembly it's assembly also it is placed. I mean we are going to assemble in 3D printing itself.
follow for metal printing, we've got a link in the description below that covers everything you need to know. As I mentioned earlier, there are several other printing technologies that are becoming popular alternatives for producing metal parts that are not DMLS or SLM. Metal binder jetting is one such example. Its unique way of producing parts makes it perfect for low to mid-volume production runs. Binder jetting builds parts by depositing a binding agent onto a thin layer of powder through inkjet nozzles and slowly builds the part up one layer at a time. The result of the printing process is a weak part that's held together only by the binding agent. To achieve a strong metal part, we need to take the print and put it into an oven to burn out the binding agent. The parts are then removed from the oven and then sintered to fuse the metal powder together, resulting in a strong cohesive component. Metal extrusion, like the Metal X printer from Markforged, is a great low-cost 3D printing metal alternative. Like FDM, metal extrusion builds a part up layer by layer by extruding material through a nozzle. Unlike traditional FDM though, the filament is impregnated with metal powder. After printing, the part is placed in an oven and the polymer in the filament is burnt out and we're left with a metal powder part. This is then sintered to achieve a strong, robust
the meaning of
component.
robust?
Binder jetting and
Robust.
material extrusion are
Anyone? Robust meaning anything? He is saying robust component. It is capable to have the robust component. What is that meaning? Hello? Unmute yourself by simply admitting in this session. 369. Hello? Hello? What is meant by robust? Robust component, robust. Very strong.
Robust, sir.
Robust means
హార్డ్
very strong.
సార్ హార్డ్ సార్.
Okay, that is very strong. It represents strongest component. Okay.
Often cheaper than traditional metal printing technologies, and they offer more design freedom. But it's important to keep in mind they require a significant amount of post-processing, and this can add lead time and cost. So let's do a quick recap. Metal 3D printing is an industrial process best suited for complex, high-performance parts. It offers a lot of design freedom over traditional manufacturing techniques, and you get all the benefit of your parts being made of metal. However, costs are high, build volumes are small, and parts require a lot of post-processing. It's also important to keep in mind design is difficult, and there's a large dependence on support structures to ensure you get a good print. We've only just scratched the surface of this awesome but highly complex 3D printing technology. I would highly recommend checking out the guides below in the description for a much more detailed dive into the world of metal 3D printing. This video is based on the 3D printing handbook. Every week, we're giving away 10 copies to new subscribers to this channel, so make sure you subscribe now.
Okay, let me end this session by conclude. I mean, we are having a, so just I would like to have given some information. Please check what are the companies providing 3D printing machines. Today you have to check what are the companies which is developing the 3D printing machines. So everything is available in internet itself. Just go through it. Okay, I'm ending this session.